This is Josh White with JW Math Tutoring. Today's video is going to cover 11 additional problems from the June 2024 Digital SAT, specifically the math section. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Just before I begin going over 11 more problems from the June 2024 Digital SAT Math section, a couple things to keep in mind. First of all, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. Also, don't be overly concerned with the amount of time spent on each question here because, not only for some of these am I showing multiple methods to solve them, but I'm also explaining as I'm going along. Whereas if you're actually completing this question on a test, you're not going to be spending the time doing that. You're just working through the problem, getting the answer, and then moving on to the next problem. So even though some of these questions might be 3, 4, 5 minutes long of explanation, the actual solving is not that long. All right, first question we're going to look at is just a basic quadratic function. We have here some points. So basically, you're given the point, 0, 0, and you're also given a point of 8, 1024. So we can just go to Desmos and we can plug everything in. We're going to use basically the vertex form of a quadratic function. And you can plug both points in. Really, though, you only have to plug in one because when I do the regression, I have to plug in the h and k values. If you don't do that and you just plug in the 2 points, Desmos doesn't know that the 8, 1024 is the vertex, and so it will not return the necessarily correct answer. All right, so let's go to Desmos and let's plug in points. Again, you actually don't need to plug it in, so I will show you. I'll just skip that and just show you. Because all we really need is the a value here, okay? So it returns a is negative 16. So that means the actual equation is y equals negative 16 times x minus 8 squared plus 1024. Now you would just plug in 2 for x. I mean, they give it as t in the problem, but it's essentially functioning the same as, x in my example. So there's multiple ways you could do this. You could technically, let me just expand this a little bit. You could technically do x equals 2, and then you're just looking for the intersection. But the problem is because the values, his value is going to be so large, it's going to be in the 400s. It's like you can't easily see the intersection without zooming out and then zooming in. Now, yeah, if you click on it, it will highlight the point. It's going to be 448. But what I would probably recommend for something like this is just going ahead and, typing in the equation and then filling in the value of 2 for x. So right there, I do that, I get 448. That's my correct answer, and I can move on to the next problem. Although, actually, sorry, one thing I do want to show you here, and again, this is why, I'll show you why you have to put it in, have to put the vertex in the regression. So let's say you don't do that, okay? So let's say, notice here, if I add the point, it doesn't change anything. But let's say instead, I type it like this. Okay, so what happens is it returns an answer. It gives me values for a and h and k, but this is not what I had listed there. Notice the a value is different, the h value is different, the k value is different. So the problem is I'm only giving Desmos 2 points, but there are 3 constants it has to find, a, h, and k. So that's why it ends up giving me a different answer, which is not the one I want, because it's treating 8, 10, 24 as just a general point on the graph. It's not treating it specifically as the vertex or the maximum value on the graph, okay? So that's why you have to put the 8 down here and you have to put the 1, 10, 24 here to actually get the correct answer. All right, next question. We have something that deals with similar triangles. So I'm just going to draw a couple graphs here or I guess some pictures would be a more accurate description of some triangles. So we've got P, S, PT and VQX. Okay, we know that S and Q are both 120 degrees, obtuse angles, and we know PT is 28 and VX is 21. All right, and then this is asking about some statements where uh, it gives us some information and wants to know, is this sufficient to prove the triangles are similar? So, a couple things first. Three methods to prove similarity: AA, angle, angle, SAS, side, angle, side, and SSS, side, side, side. Okay? The S's stand for pairs, a pair of proportional sides. The A stands for a pair of congruent angles. So far we've got one A, one pair of congruent angles. Now, one other thing to note too. I believe the way that these answer choices are worded, in like choice C, what it's saying is that both are sufficient independent of each other. In other words, it's saying that one on its own is sufficient and two also on its own is sufficient. The way that it's worded like this, it is not stating that you need both one and two. It is saying one and or two are sufficient. Okay. All right. So with that being said, first of all, notice the ratio of PT to VX, 28, 21. If you just divide it by 7, it reduces to 4 over 3. So that ratio matches the same, scale factor ratio in these two things we're looking at. So the ratio of PS to VQ is 4 to 3 as well, which is whatever. Say it's 4, say it's 3. It doesn't really matter. Notice here we now have one pair of congruent angles. We have two pairs of congruent sides, but two pairs of proportional sides, but the angle is not included. In other words, for SAS, we need the angle to be between the two proportional sides, the two pairs. So the congruent angle would have to be angle P and angle V in order for number one to be enough to prove these triangles similar. Okay, because there's no SSA. So one is on its own is not sufficient. Get rid of this, get rid of this. And when we check two, so let's say this is 4, this is 3. Okay, so now when I'm looking at these two sides, here and here, the same thing is going to be true. I'm going to have now, because this bottom part we're ignoring, pretend that we don't know anything about this down here. I have one pair of congruent angles and I have two pairs of proportional sides, but the angle is not included. The angle is not between them, so we cannot use SAS again, and there is no SSA for similarity. Therefore, this is incorrect. The correct answer for this is D. Okay? Neither one on its own is sufficient to prove similarity between these two triangles. All right, moving on. Next question. We have problem number 14. It deals with a couple different variables and two equations. So all we have to do to solve this is the following. Basically set these equal to each other, and then we're going to solve for n. So what I did first is, by the way, one thing to note, this is supposed to be the 8th root of p to the 7th. It's not 8 square root p to the 7th. I believe it's the 8th root of p to the 7th. So I rewrite that as p to the 7/8. And then on this side, I've got t to the 4/3. What I did is I raised both sides to the 3/4 power. I did that because then that gives me just t on the right, and on the left it gives me p to the 21 over 32. Okay, you just multiply because we're raising to a power. Now I can plug that in for t in the first equation. So p to the 21 over 32 equals p to the 3n minus 1. Now these two expressions have the same base, so I can just set the exponents equal to each other. Now this, once you get to this point, we can just go solve it in Desmos, or you could do it by hand, doesn't matter. But 21 over 32 plus 1 is like 21 over 32 plus 32 over 32, which is 53 over 32, and then you divide by 3. So n turns out to be 53 over 96. Okay? Now, the way you could check that is we could go to Desmos, and we could do the following. We could, basically we're going to see here is, if we plug in this 53 over 96, oh, by the way, just so you know too, you could also grid the answer in as 0.5521 or just 0.5520, which is just 0.552, or 0.552. You can give the decimal form as well, the equivalent expression. Okay, so what I'm going to do is I am going to do, first let's define n as 53 over 96, okay? Then I'm going to do p to the 3n minus 1. There we go. Let's add a slider for p. We'll just pick whatever number. Okay, so that is equal to t. Okay, I'm just going to use capital T, but whatever. Now we want to check is, if we do capital T to the 4/3, all right, we get this number. Is that number also equal to the 8th root of t to the 7th? So let's go down here. Well, you could also do it p. You could just type p to the 7/8, by the way. Like, I'm just putting this in so it matches. Okay, so now it checks and it confirms that it does. So in other words, I chose a value for p. Based on that value, I calculated what t is. Then I plugged the p value into the right equation. I plugged the t value into the right side of this equation, p value to the left side of it. And I checked, do those two expressions equal? Is t to the 4/3 equal to the 8th root of p to the 7th? The answer is yes, these two numbers are equal. That's how we can confirm that the answer is correct in Desmos. It doesn't help us solve it, but that is how we can go ahead and confirm it. So we have the right answer for this one. And again, you could also put 0.5521 or 0.552, and you could also add the 0 in front if you wanted to. All right, next up, we have a quadratic function, and we know two of its x-intercepts. We know that a is an integer greater than 1, and they want to know what's a possible value of a plus b. So first, I will show you how you could do this by hand, and then after that, I will show you the Desmos method. So by hand, what you would do is you would notice that the vertex is basically the average of your two intercepts. So 7 plus -2 divided by 2 is 5/2, which is 2.5. So that's my h value for my vertex. That's also equal to -b over 2a. And the reason that helps me is because I can rearrange this, I can cross multiply, and I can get 5a equals -b, or b equals -5a. All right, so why is that helpful? Because if I now take the expression a plus b, and I replace b with -5a, that just simplifies to -4a. So if you know now a is greater than 1 and is an integer, you can just plug in 2 or 3 or 4 or 5, and you just go through and you get these various values, and you basically see -8, -12, -16, -20. You look at your answer choices, because this is going to be a multiple choice question, and you see which one matches. Which of these answers do you see in your multiple choice thing, and that's going to be the correct answer. So this is the method to do it by hand. Now, here is how you could do it in Desmos. So let me clear out all the stuff from the last problem. What I'm going to do is put my two x-intercepts in a table. I'm going to set a slider for a, set my step value so it's only an integer. I'm going to start it at 2 because it tells me it's greater than 1. So the first integer after that would be 2. Come on now. There we go. Expand this a little bit. All right. So now you could do a plus b, and you get -8. And then you could say, okay, what about if a is 3? Well, then it's -12. If a is 4, -16, a is 5, -20, and so on and so forth. 6, 7, blah, blah, whatever. And again, you keep going until you see the one answer that is in the multiple choice answers. That's correct. So that's how you could solve this problem entirely in Desmos. Next up, question number 16. This one deals with the partial circumference of a circle. Okay, so all you really have to do, honestly, for this one is just take the partial circumference expression, which basically this is like 60% of the circumference because 3/5 is just 0.6. You're just multiplying the whole circumference times that. But if you multiply it out, you get 6/5 pi r, and you set that equal to kr, and then you just solve for k. And for the r, we plug in 4 because the radius is increasing by 4. So k is just going to be 24/5. So you could put that in, or you could also put in 4.8. And that's the answer. Now, you could also do this using picking numbers. And so what I would do is I would say, okay, let's say the radius is 1, then let's say the radius is 5. We'll calculate these two expressions and then subtract them and get our answer. So if the radius is 1, it's just going to be basically 6/5 pi times 1, which is just 6 pi over 5. And if the radius is 5, it's going to be 6 pi times 5, which is just 6 pi. Or actually, what I'm going to do is I'm going to leave it as 30 pi over 5. And I'll show you why in a second. So I actually do not want to reduce it. So now let's go ahead and subtract it. The radius increased by 4, so how much did the partial circumference increase by? I.e., what's the difference between these two? So 30 pi over 5 minus 6 pi over 5, it's 24 pi over 5. Again, k is the number without the pi, so 24/5, or again, we get, 4.8. Same thing. So that's how you could solve this problem. Correct answer, 24/5, 4.8. All right, next one deals with a cone, specifically its surface area, area of its base, and its volume, and we want to find the slant height. So think about a cone. Kind of here's a general picture. Here is its radius. Here is its height. And then the slant height is technically going down the side. This, they usually use L. It's basically the hypotenuse of this right triangle. So we know the area of the base, which is a circle. Okay, so the formula is pi r squared. So if we set that equal to 16 pi, notice the square of the radius is 16, or the radius will be 4. Now we go to the volume formula, which is 1/3 pi r squared h. So we've got 1/3 pi. I already know that the radius squared is 16, so I can just plug that in and then times h. And we set this whole thing equal to 32 pi. The pi's cancel out. You can go ahead and you can multiply by 3, and you get 16h equals 96. Divide by 16. The height for this cone equals 6. So now you got a right triangle. One side is 4, one side is 6, and we're solving for the slant height. So it's basically 4 squared plus 6 squared equals L squared. 16 plus 36 equals L squared. 52 equals L squared. L is the square root of 52, or in its simplified form, just 2 root 13. So that's going to be your correct answer. This one I'm assuming is a multiple choice, not a student-produced response. And you would just, select that obviously from the answer choices. Next up, here we have a word problem, which has been very common. We've seen it on multiple tests. It's also on one of the Blue Book practice tests. They just changed the numbers, or they changed the number of days, but the basic setup, the basic format, is all the same. So one method you could solve this is kind of like the traditional way, which is $410 for the first day of work plus $205 for every other day. So when you set it up, it has to be x minus 1 because the first day is already counted. The 205 is only multiplied by the number of days like after the first day or not counting the first day. So when you do that, you get 410 plus 205x minus 205, and that just simplifies to 205x plus 205. So this is going to be your final answer. Now, a lot of people automatically choose as their answer 205x plus 410. Okay, they see this right here and they think this is the correct answer because, well, 410 is like your initial amount, the starting amount. So you have that's your b, y equals mx plus b, and it's 205 per day. So, well, that's their slope. That's your m. That's what multiplies by x. So this seems to make sense. But again, this is wrong because the 410 counts the first day. The 410 is not like an initial charge when there's 0 days of work, okay? The 410 counts the first day. So when you plug it, like if you plug in x equals 2 to this expression, all right? So if you do 205 times 2 plus 410, you're going to get 410 plus 410, which is 820. That does not match what 2 days of work should cost according to the problem. 2 days of work would technically be 410 for day 1 plus 205 for 1 day after that, which would be 615. So this is wrong. Do not fall for that. Do not select that as the correct answer. Next up, we have a question dealing with percentages. So we've been seeing a lot of these similar questions in the SAT where it's like relating A to B and then maybe B to C or A to C, and then eventually they ask to relate the other two variables. And you also have to once you get the number here relating B and C, then you have to divide it by 1,000. But it's actually not that bad to do. So first equation is going to be A equals 4.94b because 494% as a decimal is just 4.94, Percent to decimal, move it over 2 places to the left. Same thing is true for A to C. So this is going to go over 1, 2. So it's going to be equal to 0.00071c. Now, we can easily set these equal to each other because they're both equal to A. So I'm just going to go up here and copy this down. All right, so now with this equation, we want it to be P percent of B is C, meaning we want C alone by itself and B on the other side and some number in front of B. That number is going to be the P in our problem. So you just divide by 0.00071. Okay, 0.00071. This I'm actually going to go to Desmos just because we have to do some calculations here. All right, so I'm going to 4.94 and divide it by 0.00071. So that means the equation I get is 6957 point, it doesn't really matter because I'm going to use the exact value, I'm just going to 75 approximate it, okay, times B is equal to C. So this is my p-value, but I have to convert it to a percentage. So that means I have to multiply it by 100, technically by 100%. So because I want the percentage value I want P to be expressed as a percentage, not in its decimal form. So that means the number that is being divided by 1,000 is technically going to be 695,775, and then plus the extra decimal stuff after that. And then again, that gets divided by 1,000. That's going to be my final answer. So I jump back to Desmos. What I'm going to do is I'm going to take P, multiply it by 100, and then divide by 1,000. Now, technically, it doesn't matter that like the P is listed over here separately instead of on top of the fraction. Notice it, so it's 695.77. That's my correct answer. And I'll just show you that by just getting and writing it this way. Okay, so again, same answer. So we get 695.77. If this was a student-produced response, you would do 695, you could do 0.7, you could do 695.8. Either one would be correct. But I'm guessing this would probably be a multiple choice. But if not, again, either of those would be fine because you can round or you can truncate, and you can only fill up 5 total character spaces for a student-produced response. All right, number 20 here. This is a predator-prey question. This seemed to be a very common question on the June 2024 test. Easiest way that I find to solve this is to start with the same value for each, okay, which is 100. I mean, obviously you have to start with the same number because it tells us that there are the same number, but what I meant is the easiest way is to use 100 as your starting value. So the number of prey increased by 1,700%, okay? So 1,700% is equivalent to 17 as a decimal. So you take 100 and you multiply it by 17. That's 1,700. But that's the increase. In other words, you have to add that to the original 100 to get the total number of prey after the increase as 1,800. Following the same pattern for predator, 350% is 3.5 as a decimal. Multiplying it out, you get 350. Again, that's the increase added to the 100 you started with for 450 predators. Now, the number of predators is what percent less than number of prey. So all we have to do is find the difference between them. 1,800 minus 450, which is, so it's 1,350. Number of predators is 1,350 less than number of prey. And then to convert that to a percentage, we divide that by the number of prey because that's what's listed second, in this expression. So 1,350 divided by 1,800, that just comes out to 0.75. So as a percentage, of course, it's just 75%. So correct answer for this one is just 75%. And again, I think it's so much easier to do this just picking numbers using actual numbers. I'm not going to bother going through and calculating this out with variables, like choosing whatever, x to be the initial amount of each and then adding 17x and adding 35 or 3.5x and whatever and going from there. Just so much easier, I think, to do it this way with actual numbers. All right, next up we have an exponential function dealing with coefficient. And basically what's happening is you have a function, you plug in 1 to the function, and you get some answer. They want to know for which of these functions do you see that answer you get as either a base or as the coefficient. So I will tell you just right off the bat, the answer is going to be letter B right here. All right. The reason why that happens is because, notice, if I plug in 1 for x, the exponent, which is 1 minus 1, turns into 0. And anything to the 0 is 1. Anything times 1 is that anything. So if I plug in 1 to equate the equation in B, function in B, I get an answer of 121. We'll call that K. And I see that same exact value of K as a coefficient in the problem right here. Okay? If you try to go through the others, and I'll just do this in Desmos, just real quick as an example to show you, to confirm. So if we do it for this, okay, we get 24.2857. Do I see 28.2457 as the coefficient in front or as the base? No. Okay, let's do C. 7.6. And now this one is just raised to 1. Okay, so for C, I get 99.96. Is that the coefficient in front? No. Is that the base? No, it's not 2.1. Last one, D. Now we'll make it 1 plus 1, technically 2. 146.412. Is that the coefficient in front? No. Is that the base? No. Therefore, B is going to be the only one where the y value you get as your output when you plug in 1 is equal to the number in front. Okay? Last thing to mention about this one as well. Basically, the trick is that whatever this x value is inside here, you're going to choose the function that has x minus that value as your answer. So, for example, if this was 2, then A would be the correct answer. If this was -1, then D would be the correct answer. Okay, because it's technically like x minus -1, which is the same as x plus 1. Okay, so that's the trick, really, the shortcut to doing this problem, do a problem like that. All right, last question on this part 2, going over the June 2024 digital SAT math questions. So in this question, this might look tricky or confusing, but it's actually really simple and you can solve it very quickly. So absolute value equations will only have one solution when the absolute value expression is equal to 0. So technically, this will only have one solution when this expression is equal to 0, and the solution is just going to be 3. Now, that's irrelevant because they don't care what the solution is. They want to know what the value of k over 4 is. Well, 0 over 4 is just 0. So correct answer to this one is just 0. That's it. Any other number over here for k, you're going to get two solutions because, you set up like x minus 3 equals 1, x minus 3 equals -1. However, when it's equal to 0, you will only get one solution because there's no positive, by the way, it should be -1. There's no positive 0 and -0. It's just 0. So correct answer to this one is just 0. All right, so that was 11 more questions from the June 2024 digital SAT math exam. These were all crowdsourced from Reddit. If you have any questions or comments, please do leave them below. Also, check out part 1 of questions from the June 2024 math exam. In addition to that, check out, I think it's 10 or 11, I can't remember. I think it's 11 questions from the May 2024 exam as well, that I went through. Also, please do check out, my Desmos hacks videos or my solutions to the official practice tests. Otherwise, if you like this video, again, please do give it a thumbs up, subscribe to my channel, sign up for notifications. And again, be on the lookout for more digital SAT math related content. And lastly, if you are watching this before the August 2024 exam date, good luck on that exam as you're preparing for it.